All of you are getting my voice on screen. Those are attending in online. Sure. Guys, please confirm to me. All of you are getting my voice on screen. Those are attending in online. Guys, please confirm to me. All of you are getting my voice on screen. Those are attending in online. Please confirm to me, guys. All of you are getting my voice on screen. Those are attending in online. All right. Good afternoon, guys. And check it what we completed in the last session, what we have seen there in the last classes. I think so. We are discussing about the differences between Java and other programming languages. Here we are discussing in the differences between Java and other programming languages. Already we started first difference we completed, and we are discussing about second difference. All right, now let's see this, what exactly the second difference here. And before this, one more time, I'm requesting to everybody, those who are not having this classes notes URL, now try to use this URL to get daily classroom notes. Directly you can open this URL in the browser. There we are able to see the document, whatever the document here I'm typing now. Every content, every document here we are able to get with respect to our classes. There I'm going to provide, but this is of course temporarily I'm providing this. Once by moving on to the content, then at one particular point I will give permanent link to you. This is for the sake of introduction only. Temporarily I'm giving this link to you, but meanwhile we can utilize this. Okay. All right, sir. Let's move on to the content. Try to understand the content here. What exactly the content here, the topics here we started there, differences between Java and others here we started. Where the very first difference we understand, that very first difference is C and C++ are static programming languages, but Java is a dynamic programming language. If any programming language allows static memory allocation at a compilation time, that is, what's the meaning of this static memory allocation at compilation time? That is, memory allocation is going on at what time there? At a compilation time. So then that programming language is called as static programming language. Examples for static programming languages are what? C and C++. In C and C++ applications, memory will be allocated for the primitive data types at a compilation time only, not at execution time. If any programming language allows dynamic memory allocation, that is the memory allocation for the primitive data types at a runtime, then that programming language is called dynamic programming language. In Java applications, memory will be allocated for the primitive data types at a runtime only, not at a compilation time. Okay, right. There are given some representation for the sake of introduction. I given some diagrammatic view. Understand this diagrammatic view, then what is the meaning of this compilation time? What is the meaning of execution time? What is the purpose of compilation? Tell me, what is the purpose of the compilation? Two reasons why we are performing compilation. What are the two reasons? No, to translate program from high level representation to low level representation. That is one reason. And the second reason is what there? To check the developer's mistakes in a program. To check the errors in our program. Again, here we have to use what there? Compilation process. This is a point what I'm telling to you. Next one is after that. Second difference here I given, already we started but not completed there. Then up to half of the difference I completed. What is that second difference here we are having? Preprocessor is required in a C and C++, but a preprocessor is not required in Java. Okay, preprocessor is required in C, C++, but preprocessor is not required in Java. First of all, I have given clarity what is preprocessor and where is the location of the preprocessor in our programming languages. If you observe the diagram, already I given the diagram here. So first of all, C program I have taken. We compiled the C program. There we got some .exe file. After getting .exe file, there we are executing that program. Then we are getting output. This actual process. If we open this compilation, where 4 phases are available. What are the 4 phases in compilation there? Preprocessor, compiler, assembler, loader, link editor. Again in compiler, how many phases are existed? 6 phases are existed. What are the 6 phases? No, lexical analysis, syntax analysis, semantic analysis, intermediate code generation, code optimization, and code generation. All the phases are not required for us. No need to understand all the phases immediately. But my intention of giving this diagram is what? I want to show the location of the preprocessor, where in general preprocessor is existed in programming languages. That's a point here. There we understood clearly preprocessor is existed in the compilation process. The pre-processing is the first phase of the compilation. In the compilation, pre-processing is the first phase. Okay, that's the location of the preprocessor here. We understood. That's okay, fine. Next one is after this, all of you observe carefully. What is the requirement of the preprocessor in C and C++? That point here we are going to understand. Right. So now let's see this. What is the requirement of the preprocessor in programming languages? No, observe carefully. What is the requirement here? In C and C++, the complete predefined library is provided in the form of header files. In C and C++, the complete predefined library is provided in the form of what? Their header files. Clear? In the form of header files, the complete predefined library is provided. Examples for the header files are what there? stdio.h, conio.h, math.h, and so on. These are the examples for what their header files. Okay, good. If we want to use a predefined library in C and C++ applications, first we have to include header files into C and C++ applications. To include header files in C and C++ applications, we have to use hash include statement. What statement here we have used there? Hash include statement. Examples are given. Hash include stdio.h, hash include conio.h, hash include math.h. Then I given some internal flow. If I prepare any C program where if I use these hash include statements, and if we compile that C program, then what compiler will do, what preprocessor will do, part of the compilation. There are given some points here. Preprocessor will recognize all the hash include statements. Preprocessor will read all the provided header files names. Whatever the header files names we provided along with hash include statement, preprocessor will read all the header files names. Preprocessor will check whether all the provided header files are existed or not in the C software. If the provided header files do not exist in the C software, then preprocessor will raise an error. Preprocessor will raise an error if they are not existed in C software. Right. So now let me give clarity. No, exist or not in C software. Okay. If the provided header files do not exist in the C software, then preprocessor will raise an error. Good. Next point. If the required header files exist in the C and C++ softwares, then preprocessor will load the required header files to the memory. This type of loading predefined library at compilation time is called as what there? Static loading. That's it. In C and C++, preprocessor is required to recognize hash include statements in order to load header files content into the memory. That's it. Now, this is the clear-cut awareness on like what there. Why preprocessor is required in C and C++. I'll forget my point or not? Right. Let's come to the point here. Now, let's understand this. Why preprocessor is not required in Java? Why preprocessor is not required in Java? We have to understand this point. Right. All of you observe carefully. In Java, understand clearly. In Java, the complete predefined library, recognize this, what I'm telling there. The complete predefined library was provided in the form of classes and interfaces in packages. The structure is available like this inside the Java. Got it or not? Package is available. Inside the package, classes and interfaces are existed. There only predefined methods, predefined functions, predefined variables, all these are existed. So the point is what? In Java, the complete predefined library was provided in the form of classes and interfaces in packages. Clear? After that, examples for these packages, no? If you have to the examples for packages, no, you can understand java.io, java.util, next one java.sql. Just these are package names only, just names of the packages. I'm not importing so far. Just names of the packages I'm giving. Like this, so many packages are available. Not only this, so many packages are existed. Okay, fine. In Java, the complete predefined library was provided in the form of classes and interfaces in packages. That's okay. Next one after that, listen carefully. In case of C and C++, library was available in the form of header files. To include these header files to the C program, we have to use what statement there? Hash include statement. Similarly, in Java applications, observe carefully, all of you know, in Java applications, if you want to use predefined library, then we have to include packages. Then we have to include what their packages. It's not a right thing to use include, no, but for our understanding purpose, I'm using include statement. All right, sir. So then we have to include packages in the Java applications. In the Java application, to include packages, right? Include packages in Java applications, we have to use which statement there? Import statement. All right, sir. In Java applications, if you want to use the predefined library, then we have to include packages in Java applications. All right, sir. To include packages in Java applications, we have to use the import statement. What statement here we have to use there? Import statement. Let's see example here for this. Example, how we are going to provide these import statements? Understand it now? Import java.io.star. Here star represents all classes and interfaces from java.io package. Here star represents all classes and interfaces from java.io package. All right, so that's why import java.io.star. All right, so next one is what there? Import java.util.star. Again, star I'm telling there. But where to use star, where not to use star, we will discuss in the future, not immediately. But point is what? In java.io, so many classes and interfaces are available. I want to get them. In java.util package, so many classes and interfaces are available. I want to get them. That is a requirement why I'm writing what their import statement. Clear. Next one is after that. Here we have to understand next one. Import java.sql.star. Even the purpose of IO, purpose of util, purpose of SQL is also be not required. Just understand it. These are the package names. Inside the packages, some predefined classes and interfaces are available. That predefined classes and interfaces here we are getting. That's it. Not more than that. Right. Now this is exactly the meaning of like what their import statements. Fine. But I have a question now. How these import statements are working? Then how they are able to provide our library to the Java program? What exactly the internal story? Now try to understand it now. When we compile a Java program, containing package statements, then compiler will perform the following actions. What compiler will do? Observe carefully, all of you know. Then the compiler will perform the following actions. Number one, compiler will recognize all the import statements. Similar to hash include, but small variation. Compiler will recognize all the import statements. Then what next one get? After this, compiler will take all the provided packages names. Compiler will take all the provided package names. What are the package names? No, java.io, java.util, java.sql, like this. Compiler will take all the provided package names. Then after this, compiler will check whether all the provided packages exist or not. Compiler will check whether all the provided packages exist or not in a Java software. Okay, right, sir. Next point. If the provided packages names, if the provided packages names do not exist in the Java software, then what compiler will do? Then compiler will raise an error. Compiler will raise an error. Like what is that error even that compiler is able to raise? No. That error message also like what their package XXX does not exist. Then the error message also I'm telling to you clearly, no directly understand it now. Alright, sir. If the provided packages names do not exist in the provided in the Java software, then the compiler will raise an error like what their package XXX. What is this XXX? No, it may be java.io, java.util, java.sql, whatever the package name is specified, which is not there in the Java software, that package name is going to be provided. Package XXX does not exist. This is what exactly the error message here we are able to get. Clear or not? Next one after that. If the provided packages or if the provided packages exist in the Java software, then the compiler will not write. Then the compiler will not raise any error. Compiler will not raise any error, but remember this, up to now the flow is okay. It's almost the same as C and C++ only. Observe carefully. In C and C++, what happened? Preprocessor will recognize hash include statement. Here compiler recognize all the import statements. Preprocessor read all the header files names. Here compiler reads all the package names. Preprocessor will check them in the C and C++ softwares whether they exist or not. Here also compiler is checking them whether they exist or not existed. In the case of C and C++, if the provided package, that means header files are not available in C and C++, their error will be raised. Here also, if the provided packages are not available in Java software, error will be raised. In the case, if header files are available in C and C++, if the header files are available in C and C++, no, then what preprocessor has done there? Loaded directly the header files content loaded to the memory at a compilation time. That is what their static loading. But in the case of Java, what is going on? If the provided packages exist in the Java software, then the compiler will not raise any error. Remember this. At the same time, the compiler will not load any package content to the memory. At the same time, compiler will not load any package content to the memory, even though compiler knows about it that packages are available in Java. Even though packages are identified in Java, still compiler will not load any package content to the memory. Please recognize this point here. I'm giving one small note type of point to you. Now try to understand this. What is the note here? I'm giving clarity. Now try to understand it. In Java applications, compiler is responsible for checking. Compiler is responsible for checking whether the packages are existed in the Java software or not. Compiler is responsible for checking whether the packages are exist in the Java software or not. Got my point or not? If not, the compiler will raise an error. If there existed, or else maybe this total content is not required here. Just I want to give conclusion or not, where the compiler is not responsible for, where the compiler is not responsible for loading predefined library to the memory. That's it, guys. Please read out this note, what I've given there. No, in Java applications, compiler is responsible for checking whether the packages exist in the Java software or not. Where the compiler, that means the compiler is not responsible for loading predefined libraries to the memory. Better not. The compiler is not responsible. Compiler is not responsible for loading the predefined library to the memory. That's clear? All of you are getting clarity on this, no? Okay. If compiler is not loading predefined library to the memory, but who will load predefined library to the memory in Java? Who will load that predefined library to the memory in Java? First of all, tell me, all of you now tell me, who will execute Java programs? Exactly. Who is executing Java programs? No, JVM. C programs are executed by C engine. C++ programs are executed by C++ engine. Similarly, Java programs are executed by JVM. PVM, Python programs now. All right. Now the point is what there, when we execute Java applications, JVM will load the required libraries. JVM will load the required libraries to the memory. The required libraries to the memory as per the application requirement. As per the application requirement. Now I can give one more point here. You can understand clearly. It shows clearly the difference between static loading and dynamic loading. I'm telling to you, observe carefully. Even though I provided these many import statements in my Java, JVM will not load all the packages blindly to the memory. JVM will not load all these packages to the memory blindly, even if you specify these import statements. From these packages, which classes or interfaces we have used in our Java program, that classes, up to that classes are only be loaded. Even if we provide import statements, Java will not load all these packages to the memory. Okay, import statements we have written. From these import statements, which classes and interfaces are used real in our program, up to that, classes and interfaces are only be loaded. Yes, sir. All of you get my point or not? Not complete package, not entire packages, not this total content here. Right or not? Say for example, I specified, I imported 3 packages here. Unfortunately, in my Java program, I have used the classes and interfaces from util and SQL. That's it. I have not used anything from java.io. Now tell me what JVM will do now. Will it load the total java.io, java.util, java.sql totally? No, it will not touch even java.io. Compiler might be checked whether it is available or not. Up to that, it's okay. But at runtime, what JVM will do? JVM, if you are not using any library from java.io, JVM will not touch that java.io. It will not java.io. It will load the classes and interfaces from what there? Java.util and java.sql as we have used them in our Java program. For example, listen carefully. In java.util also, how many class and interfaces are available? Say for example, 100 class and interfaces are available in java.io really. In the predefined library, 100 classes and interfaces are available in java.util. But in my Java program, really I have used 2 classes only. In my present program, I have used only 2 classes from java.util. How many classes are loaded by JVM now? JVM will not load the entire java.util package. JVM will not load all 100 classes to the memory. What classes we have used from java.util in the present Java program, up to that classes are only loaded by JVM. JVM will not load all classes from the respective package. Of course, you might be specified star. Star is representing that what? All are available. What you require, load them. What you don't require, don't load them. But they will be available for you. But they are not loaded so far. They are available to you. Out of them, what you require, load up to them. If you don't require them, don't load them. Sir, got my point or not? So this is the meaning of like what there dynamic memory. That means dynamic loading. Now tell me, which one is saves our memory? Which one is able to save our memory? Which strategy is able to save our memory? Is it a static loading or dynamic loading? In the case of static loading, what is going on? For example, if static loading is going on there, what is going to happen there? Compiler has to load all the packages to the memory. Compiler has to load what there? All packages to the memory. At each and every package, all classes must be loaded to the memory. Whether we are going to use them or not, we don't know. But first of all, they will be loaded. This unnecessary loading or not? Unnecessary memory wastage or not? Got my point here? Unnecessary loading or not? Unnecessary memory wastage or not? Answer my point clearly. No. So this is the difference between static loading and dynamic loading. Which loading is preferable in our applications? No. Dynamic loading. Which loading saves our memory? Dynamic loading, not static loading. That is followed by Java, but the static loading is followed by what there? C and C++. So which programming language is able to utilize memory effectively? Effective memory utilization is available where? In a Java or in a C or C++? Come on, in a Java. Why in Java? Java follows dynamic memory allocation, but C and C++ are following what their static memory allocation. In static memory allocation, everything will be loaded without thinking about the requirement, actual requirement. But in the case of dynamic loading, up to how much we require, up to that only loaded. Unnecessary loading is not going to be happen in the case of what their dynamic loading. Right, sir. Now this is another point here we can understand. But anyway, here the point is like what there, when we execute Java applications, JVM will load the required libraries to the memory as per the application requirement. Observe carefully. Here, loading predefined library, here loading predefined library at a runtime is called, here loading predefined library at runtime is called dynamic loading. Is called as what there? Dynamic loading. That's it. Loading the predefined library at runtime. Loading the predefined library at runtime is called as what there? Dynamic loading. Alright, sir. That's it now. Let's come for the conclusion. What is the conclusion here? Why preprocessor is not required in Java? Yes, sir. All of you are getting it now? What is my conclusion here? Why preprocessor is not required in Java? This is a question here. Right, sir. What is the answer for this question? No. In Java, preprocessor is not required. In Java, preprocessor is not required. Why? Because in Java, hash include statements are not existed. Again, why? Because in Java, header files are not existed. Header files are not existed. In Java, what are the conclusion I'm giving there? In Java, preprocessor is not required. Why? Because in Java, hash include statements are not existed, do not exist. Why? Because in Java, header files are okay, fine, exist. Header files are not existed. Got it or not? Because of that reasons here, preprocessor is not required in the case of Java. Okay, now tell me what alternatives are available. Now tell me, in place of all these things, what alternatives are available? Java has, come on, Java has classes and interfaces in packages. And then what next one here? And to include them, Java has what there? Import statements. Got or not? All right, sir. To recognize and execute import statements, Java has a compiler and a JVM. That's enough. Java has classes and interfaces in packages. To include them, Java has import statements. To recognize and execute import statements, Java has what there? Compiler and JVM. So indirectly what I'm telling there, we don't require preprocessor. Preprocessor is not at all required. As clear? All of you are understanding these points now? Right, sir. Just give a minute of time. Now let me, I think yesterday prepared some diagram here. Preprocessor diagram I prepared now. All of you understand this. This diagram is provided with respect to C programming language. Am I right or not? I want to convert this diagram into Java. I want to convert this diagram to what there? Java. Then what I have to do? If you want to convert this diagram into Java, then what I have to do? Alright, so now tell me what changes I have to do there, what changes I require. First of all, we have to remove what extension here? Dot C. In place of dot C, then what we have to provide there? Dot Java. Am I right or not? In place of this, then what we have to provide there? Dot Java. Right, dot Java extension here we have to provide. Again here, in Java, after compilation of the program, in C and C++, after compilation of the program, what files we are getting there? What files we are getting there? .exe. It's a bit confusion in C and C++. .obj, .exe, .ai, different files now. But in the case of Java, it's very straightforward. Before compilation, .java. After compilation, dot class. What next one here? No, dot class files in the case of Java. Dot Java in the sense dot class file. That's it. No confusion. Only these two types of files in Java. We are writing program in dot Java file. When we compile the program, compiler will generate dot class files. That's it. Not more than this. Right. Next one. After that, execution is okay. But what is not existed in Java? What is not existed in Java? Preprocessor is not existed in Java. That remaining structure is as it is. Preprocessor is not existed in Java, but remaining structure is as it is. This is the story here. What I'm trying to say, no? Right. So now let me provide this diagram here for the sake of your reference. I'm giving this diagram also. Try to recognize it. Now, listen. I think all of you might be understand clearly the concept what I have discussed here. Right. The second difference, especially preprocessor is required in C, C++, but preprocessor is not required in Java. That is the title I given. For the title I given some explanation. That everything is clear to all of you? Okay, fine. Now observe carefully. I'm asking one important interview question, guys. I'm asking one important interview question to everybody. You have to give answer for this question now. As you understood this topic clearly, up to now what I have discussed with you. Now I'm asking one question. You must give answer for my question. All of you ready for answering question now? Right? Can I ask a question now? Right. Listen carefully. What are the differences between hash include statements and import statements? What are the differences between hash include statements and import statements? As you understood clearly, whatever the content I have given up, step by step, point by point here we are going to understand that very first difference that I'm telling to you, not try to understand. What are the differences between hash include statements and import statement? This is my question. All right, very simple answers. First of all, step by step now. In which programming languages these two are existed? Where these two are existed? Let's confirm it now. All right, hash include statements. Hash include statements are available in C and C++. Very clear. But import statements are available in where there? Java. All right, this is point number one. Point number two, what their functionalities, what they're able to do, what libraries they're able to include. What libraries they're able to include in the sense, hash include statements are able to include the libraries, are able to include the libraries, which are available in header files. Am I right or not? Which are available in what their header files. Similarly, import statements are able to include the libraries which are available in what their classes and interfaces in packages. Clear or not? Classes and interfaces which are in what their packages. Clear. This is point number two. All right, sir. All of you understand clearly. Next one is What type of loading these two are supported? Static loading and dynamic loading, two things are available. What type of loading is supported by hash include statements? What type of loading is supported by import statements? If you have to this, now tell me hash include statements are supporting what type of loading there? Static loading. Similarly, hash include statements are supporting static loading. Next one is import statements are supporting dynamic loading. Supporting what there? Dynamic loading. That's it. That's okay. Then before this, one more point here I'm telling there. Who are evaluating hash include statements and who are evaluating these import statements? If you have to this points here, hash include statements are evaluated by hash include statements are evaluated by the preprocessor. Hash include statements are evaluated by the preprocessor. Tell me guys, import statements are evaluated by the compiler and JVM. The compiler and JVM. Both are evaluating this. For checking whether packages are available or not in the predefined library, compiler must recognize hash include statement. For loading classes and interfaces from these packages, no, JVM must evaluate what their this import statements. Anyway, preprocessors are evaluating what their hash include statements. Right. So now these are the points here. But I'm asking one question to you. Now try to answer for it. All of you know. Hash include stdio.h comma conio.h comma math.h. Is this syntax is possible? Is it possible in C and C++? No. What I'm asking there, is it possible to include more than one header file by using single hash include statement? Is it possible to include more than one header file by using single hash include statement? No, not possible. But what is possible actually? Hash include stdio.h. Alright, hash include conio.h. Then what next one here? Hash include math.h. That means only one header file we are able to include by using one hash include statement. A single hash include statement is able to include only one header file. But in the case of Java, what is the point I'm telling to you? Observe carefully. I want to include more than one class, more than one interface of the same package. I want to include more than one class, more than one interface of the same package. Single import statement is sufficient or not? Import java.io.star. The star is representing what there? All. Star is representing what there? All classes and interfaces from what there? Java.io. All we are able to get them or not? All classes and interfaces here we are able to get them or not? So this is what exactly the suggestion here we can understand. So now here we are able to provide like what there? Import java.io.star, that we are able to provide clearly. Sir, all of you are getting it or not clearly what I'm telling you? Okay, fine. Now, totally, all of you understand this clearly what I'm telling there. Now here the point number 5. What is the point here I'm telling there? All right, sir. To include more than one header file in a C and C++ applications, we have to use more than one hash include statement. As it to include more than one header file in C and C++ applications, we have to use more than one hash include statements. Right? Example here I'm telling there. Now try to understand it now. Here, this is invalid. All right, so these are valid here. Okay, that we can understand. But in the case of Java, to include more than one class or more than one interface of the same package To include more than one class or more than one interface of the same package in a Java file, in Java applications, we will use single import statement with a star notation. What notation here we are using there? With a star notation. Observe carefully. Now example here I am telling to you. Observe carefully here. Example. Alright, this is an example. Import java.io.star. Star is representing what there? All from the classes and interfaces. There is a fifth difference here. Now tell me, even with this concept also, in which programming language more number of finish sections are required? In which programming language less number of finish sections are available? In C and C++, more number of finish sections are required or not? In Java, less number of finish sections here we are able to use or not? So that is also be another point here we have to understand. Right, so these are majorly the differences between hash include statement and import statement. Let's see once again what exactly the points here I have discussed with you. First, what is the question here? What are the differences between hash include statements and import statements? Tell me, what is the first difference? No? Come on. Hash include statements are available in C and C++, but import statements are available in where? Java. Next one is, what next point here? No? Hash include statements are able to include the predefined library which are available in what there in the form of header files, which are available in header files. But import statements are able to include the predefined library, which are available in the form of what there classes and interfaces in what there packages here. Next one. After that, what next one here? After completion of this, right? Hash include statements are supporting which type of loading? Static loading. But import statements are supporting which type of loading there? Dynamic loading. That's okay. Fine. Next one is hash include statements are evaluated by the preprocessor, but whereas import statements are evaluated by the compiler and JVM. Right. Next one after that. To include more than one header file in C and C++ applications, we have to use more than one hash include statement. Examples are like what there? These many examples here we can understand. To include more than one class or more than one interface of the same package in Java applications, we will use single import statement with what notation here? Star notation. Example is what there? Import java.io.star. Yes, sir. All of you are getting clarity or not? Please try to remember the concepts what I am giving. At least in the very startup mode, try to assign 10 to 15 minutes of time for regular content. Theoretical concepts only. Next to 3 to 4 days of time totally. Up to introduction part is totally theoretical concepts only. Even I don't want to give much burden very first day itself. Understand it here. Gradually, step by step. Don't be hurry. Yeah, the point is what there is a permanent solution what I am providing there. If it is a temporary solution, no, in a hurry manner, I have to complete your concepts now. Right, not required to complete the concepts in that way. Then try to understand the content clearly. Clarity is important. Getting more content is important, and understanding, digesting the concept is very important. Observe carefully. Of course, you may by heart the statements. You may remember the syntaxes. With that also we can write the program. Maybe that is temporary. But if it digest the concepts, at any time, at any location, we can write the programs without having any support, without having any document, without having any material. If you remember the concepts, easily we can implement it. Simple. Take it as a challenge. If somebody else may ask a question to you, tell me why Java is great when compared with the C and C++. If this question is coming there, you should be in a position to talk about Java minimum 2 to 3 hours of time. Minimum 2 to 3 hours of time we should talk about Java. Java is great in these aspects where C and C++ are not good. You have to define yourself, right? Why? Because as you are learning Java, as you are supporting Java, definitely you have to say Java is good when compared with other programming languages. There you must have some content. The same thing I'm trying to provide. So that's why each and every point, each and every topic, try to digest. Okay, clear. Don't look the number of lines what I have typed. Don't see the number of pages I have typed. Understand the concept, what is there inside the document. Of course, maybe 100 pages of document I'm able to prepare, where the concept is single. You're not recognized. Nearly 300 pages of document I'm going to prepare in only object orientation. In only whoops, more than 300 pages of document here we are able to get. Only whoops, only object orientation. I get my point, what I'm telling to you now. So don't look on the number of pages here. If you think about number of pages, no, you may get like what there, this much of content we have to learn now. But understand the concepts. Out of this 300 number of pages, no, the concepts are only 7 to 8 concepts only. Concepts are what there? 7 to 8 number of topics only. Understand the topic. Number of pages are going to be overridden. Understand the concept. What is there inside the concept? How much content we are trying to understand? That is important. In that way, we have to understand the concepts. Right, sir? So anyway, by moving on to the content, we are able to understand everything. But now try to understand the next one. After completion of this second point here, the second difference is completed. The second point. After that, the third difference here I'm trying to understand. Now try to understand this third one here. Third one is what there. Listen, very, very important. In the point of discussions also is very, very important. So everybody must put more concentration on it. What is the third point here? C and C++ are platform dependent programming languages, but Java is a platform independent programming language. Right, sir. Java is a platform independent programming language. Definitely. In outside also some discussions are going on. C, C++ are platform dependent, but Java is a platform independent. Why? What exactly the reason why C and C++ are platform dependent? Java is a platform independent. What are the reasons here? Why this concept is coming? These questions are coming there. So by the time as you are learning Java, as you are at Java set, you must give much clarity on this particular point. You must talk more. We must give more effective reasons why Java is a platform independent and why C and C++ are platform dependent. Yes, sir. Clear to all of you know? Right, sir. Now I'm asking one question there. Before going to understand C, C++ are platform dependent, Java is a platform independent. Before understanding this point, first of all, tell me when a programming language is a platform dependent, when a programming language is platform independent. When a programming language is platform dependent, when a programming language is platform independent. What is the definition for platform dependent? What is the definition for platform independent? Okay, let me give some definitions now. By that we are able to understand it clearly. See this, I'm going to give some definition for it now. All of you observe carefully. Platform dependent programming languages definition I'm telling to you. Now try to understand it clearly. All of you observe carefully. If any programming language, right, listen, if any programming language allows its applications to perform compilation is on one operating system, sorry, if any programming language allows its applications to perform compilation and execution on the same operating system, not on two different operating systems, on the same operating system, then that programming language is called platform dependent programming language. Right, sir? Now please read out this statement what I've given there. What exactly the point I'm giving there? Now tell me, if any programming language allows its applications to perform compilation and execution both are two different processes or not? Compilation is for the sake of error checking, for the sake of translating our code from high level to low level, and execution is what there? performing the instructions, processing the instructions to get some actual results. So both are two different things now. If both are performed on the same operating system, it's mandatory not to perform on two different operating systems. It's mandatory to perform on the same operating system. Then that programming language is what their platform dependent programming language. Clear? Examples for platform dependent programming languages are what? C and C++. C and C++. Straightforward information. Examples for platform dependent programming languages are what there? C and C++. Then okay, definition is okay, examples are okay, but how can you say how C and C++ are platform dependent? How can we say C and C++ are platform dependent? We need to give some reason for it. Right, now try to understand this reason, all of you know. I'm going to give one diagrammatic representation. Everybody must follow this diagram here. Guys, all of you are following or not? Now I'm giving that actual diagram. Now try to understand it. For example, first of all, I want to prepare this diagram as per the definition of the platform dependent programming language. So this, first of all, I'm taking like what there .c file. .c in the sense, what is this? No, C program. All right, when we have prepared this C program, now immediately we have to perform compilation or not? Here we have to perform what there? Compilation. Now okay, let me take this compilation here. This process is nothing but what there? Compilation. Compilation. Nice. When we compile the C program, now tell me guys, what files here we are able to get? No. When we perform compilation, what files here we are able to get? No. Come on. When we perform compilation over C program, what file here we are able to get? Dot exe file. What file here? No. Dot exe. Not a dot class. Dot class is in what there? Java. All right. Dot exe file is generated. Okay. Right. Now here we need to execute this dot exe file. There we have to go with what their execution process. There we have to go with what their execution process. When we execute the application, there what we are able to get there? Now here we are able to get what there? Some outputs here we are able to get. When we execute the application, there we are able to get what their output. All right. Now here compilation, as per the definition, now tell me, if any programming language allows its applications to perform compilation and execution on the same operating system, then that programming language is what their platform dependent programming language. Now here compilation purpose I required one operating system, execution purpose I required operating system. Let's say for example, I want to use Windows operating system for what their compilation purpose. What operating system I'm using there? No, Windows operating system for what purpose there? Compilation purpose. Right, as per the definition, I have to use the same Windows operating system for execution or not? As a C programming language is a platform dependent programming language, I must use the same operating system for compilation and execution. For compilation, I confirmed it, Windows operating system I'm using. So for execution also, I must use the same Windows operating system or not? Yes, I must use the same Windows operating system. But for the discussion point of view, for proofs point of view, for next 2 minutes of time, I want to use different operating system for execution. Not Windows operating system, I want to use what the different operating system for execution. Just assume it, I'm using some Linux operating system for execution, not Windows operating system. What problem is going to be happen? What problem is going to be happen? Now try to understand it. If you are not getting any problem, smooth, it's okay. It supports like multi-platform. But if any problem is coming there, then we will think about it. All of you observe carefully. What problem here we are able to get? Understand it now. Guys, all of you observe carefully. Again, come back now. When I compile my C program on Windows now, what file is generated here now? .exe file is generated. .exe file contains what? Not bytecode. Bytecode is in Java. Right, sir. Now observe carefully. I'm going to give some .exe file. This .exe file contains what? .exe file contains directly executable code. Come on, .exe file contains what there? Directly executable code. Get my point or not? .exe file contains directly executable code. Okay, fine. Again, continuation I'm telling there, try to understand it, no? It is depending on the operating system which we used. It is depending on the operating system which we used for compilation. Come again, what's the point I'm saying there? .exe file contains directly executable code, and what next one here? It is depending on the operating system which we have used for compilation. That is what the meaning of it, no? That is the generated .exe file contains Windows represented executable code. Windows represented executable code. Right, sir? Now please read out this statement. What I have given there? .exe file contains directly executable code. It is depending on the operating system which we have used, for compilation. That is, the generated .exe file contains which representations? No. Come on, where we compiled our program? We compiled our program on which operating system? Windows operating system. Okay. On Windows operating system, we compiled our program in the sense, what file here we are getting? .exe file. The .exe file contains what? Directly executable code, and it includes, or it has, the operating system what we have used for compilation. Its representations are available. In this example, we compiled our program in Windows, so this .exe file contains which representations? No, Windows representations are available. Am I right or not? Am I right or not? This .exe file contains what representations here? No, Windows representations are available. Now I'm telling to you clearly, this is the point here we can understand. What representations are available? Windows representations. Okay. Now here, for our understanding purpose, I'm writing once again here. This is what the Windows represented .exe file. This is what the Windows represented .exe file. Clear? Now understand this clearly. Okay, forget about this compilation, what file is generated, just forget a moment of time. Let's understand it now. Execution here we are performing or not? Here we are performing what there? Execution. Am I right or not? Come on guys, execution here we are performing. This execution here we are performing in the sense, who is executing our C programs now? Tell me. Who is executing our C programs now? C engine. Execution we are performing in the sense, C engine is executing our code. Am I right or not? Okay. Now tell me, C engine is installed on the top of which operating system? No, Linux operating system. Now C engine is available on what there? Linux operating system. When a C engine is provided on Linux now, what's the point here we have to understand? Everybody observe carefully. Here, this is the key point. If you understand this, that entire point is very simple. When a C engine is available on Linux operating system, then what it is going to be happen? C engine is able to understand only Linux representations. C engine is able to understand only which representations there? No, Linux representations. Why? Because C engine is available on which operating system? Linux operating system. So C engine is able to understand only what representations? No, Linux representations, not any other representations. All right. Now come to the overall picture. Come again. Clearly, I'm asking no. C program we compiled on which operating system? Windows operating system. We got .exe file with which representations? No, Windows representations. Clear? All right. Now C engine is available on which operating system? Linux representations. C engine required which representations? No, Linux representations. But we are providing which representations? No, Windows representations. We are providing Windows representations to the C engine, which is on Linux, and as it is required Linux representations, how it is possible for C engine to execute Windows representations? No. Got my point or not? So as a C engine required Linux representations, it is expecting Linux representations in a .exe file. But we provided what representations there? Windows representation. Is it possible to run Windows representations on a Linux operating system? Yes. How? That representation, internal data representation, internal code representation is totally varied. Understand it now? From operating system to operating system, internal data representations are varied, not the same representation. Not in all the operating systems, not same representation in all the operating systems. From one operating system to another operating system, internal representations and conventions and everything is varied. In the case, if every operating system is following the same representation, no need to have these many number of operating systems. No need to have any concepts like platform dependency or platform independency. No specification for Java, no specification for C, nothing. Every programming language is almost all equal. But one operating system to another operating system, internal data wise, that the native code wise, executable code point of view, difference is available. Not the same in all the operating systems. Answer my point, Keno. Okay, fine. Now what we are giving there, Windows representations we are giving to the C engine on Linux operating system. C engine is expecting what their Linux representations, but we provided what their Windows representations. Where some mismatch is available or not? Some mismatch is available or not? Due to this mismatch, our program is not going to be executed. Due to this mismatch of the representations, our program is not executing now. Right or not? So if I want to execute my program here in this context, if you want to execute my program, only one option for us. What is that option here? No, only one option here we have to use. What is that option here? Don't use Linux operating system. In place of this Linux operating system, what we have to use there? Same Windows operating system what we have used for compilation, same we have to use. Now if we use Windows operating system, automatically the C engine is available on which operating system? No, Windows. Now it is able to understand what there in place of Linux representations. No, it able to understand what there Windows representations. Now our program will be executed. Now our program will be executed. Now tell me, C programming language execution is depending on the operating system which we have used for compilation or not? C program execution is depending on the operating system which we have used for compilation or not? By this now give the conclusion. No, C and C++ are what? Platform dependent or platform independent? Platform dependent programming languages. C and C++ are what? There platform dependent programming languages. Now this is the conclusion here I'm giving there clearly. Right, so now this is a diagram here I've given for the sake of you, but I'm giving clarity here now. Right, observe carefully. I'm going to give some points here now, try to understand it. No, right, sir. If we compile C and C++ programs on Windows operating system, then the compiler will generate .exe files, then the compiler will generate .exe file which contains directly executable code, and it is following and it is having the same Windows operating system, representations. All right, sir. The simple point in a simplify, I'm terminating a count here, and the simplify I'm giving clarity there. All right, sir. The point is like what there in the above context, to execute Windows represented Windows represented .exe file, we need the same Windows operating system. We need the same Windows operating system at a runtime. We need Windows operating system at a runtime. In the above context, to execute Windows represent.exe files, we need the same Windows operating system and runtime. Right, sir? Due to the above operating system dependency at runtime, due to the above operating system dependency at runtime, C and C++ are platform dependent programming languages. That's a platform dependent programming languages. Right, so see this one. If we compile C and C++ programs on Windows operating system, then the compiler will generate .exe file which contains directly executable code, and it is having the same Windows operating system representations. In the above context, to execute Windows represented .exe files, we need the same Windows operating system at runtime. Got it or not? We are unable to use other operating systems at runtime. Why? Because other operating systems are unable to represent Windows representations. Other operating systems are unable to process Windows representations. That's the point here. We can understand now. So due to the above operating system dependency at runtime, C and C++ are what their platform dependent programming languages. That's it. Next one is given clearly. Initially I've taken Linux, here also Linux I've taken, but later on I strike it off both of them. Then I convert it to what their Windows. Same Windows operating system we have used for compilation and as well as for what their execution. So this is what exactly the meaning of like what their platform dependent programming language. Yes, sir. All of you are clear about this point now? All of you are getting clarity on these points now? No response, guys. Why, sir? Why you are very much serious on my face now? Huh? Everybody is totally serious on the class there. Huh? Right. Do one thing, and today I want to leave from the class a bit earlier much. Even the topic is somewhat lengthy topic next part here. Why Java is platform independent? Minimum half an hour to 45 minutes of time I require. At the same time, maybe I have some work there, small work there at my office now. So I want to finish our session now itself. Then tomorrow I'll continue the remaining part. But don't miss the tomorrow's class. No, half of the concept only today we understood. Actually, we are talking up to now about what their C++. But we have to talk about what their Java. That is our main requirement. Why Java is platform independent, that we have to know more. But up to now what we understood there, why C and C++ are platform dependent. It's a basic, but our required point is what there, why Java is platform independent. So tomorrow I'll discuss very good content, very good conclusions I'm going to give on tomorrow about these concepts. Don't miss the tomorrow's content, right? Thank you guys. Thanks a lot. Shall meet on tomorrow. Tomorrow see the remaining content. Thank you. Yes. Anyway, then videos you are able to get, that is one thing. And backup class again you will have that. But when I'm going to take it now, I'll decide what it is. Sure, definitely backup class. Yeah, sure, sure. Anyway, then by default you can check that video. Then when backup class are coming here, I'll give it to you. Sure, thank you. డాట్ జావా డాట్ క్లాస్ మనం రాయము అది కంపైలర్ జనరేట్ చేస్తుంది